In this video, we're going to take a look at how we can compare different parts of triangles like we've been doing. The first thing we're going to have is called the triangle inequality. It says, give me any triangle, doesn't matter how big, how small, if it's acute, obtuse, scalene, etc. Any two side lengths are always going to add to more than the remaining side length. So written as an inequality, looking at this triangle here, you could say first off that AB plus BC is going to be greater than AC. You could also say that AB and AC add to more than BC. And then you could also say that BC and AC always add to more than AB. So if you have three numbers and you're wondering if you can form a triangle with those numbers, you can just check these inequalities. But there's an even shorter way to do this. So here's a trick. You really only need to check. You really only need to check the smallest side lengths. Make sure that they add to more than the longest one. So, for example, let's say we have all of these triples: 5, 6, 9, 12, 10, 8, etc. And someone asks you, can you form a triangle with these numbers being the side lengths? To do a quick check, you just look at the smaller numbers. So that first triple, 5, 6, 9. 9 is the longest one, so let's check 5 plus 6. The smaller lengths add to more than the largest one. So yes, you could form a triangle with those numbers being the side lengths. For the second triple there, 12 is the longest one, and the two smaller ones add to more than that. So yes, you could. On the third one here, you do not get more than, and it has to be more than. It can't be equal to. And we'll talk about this in class, but no, you couldn't make a triangle with those numbers. And lastly, the two smaller ones, 7 and 7, they do not add to more than 15, so no, you couldn't form a triangle with those numbers. The next part of this video, we're going to take a look at comparing two different triangles. So this is a little different than what we've seen before. The first thing is called the side angle side inequality. Some people call this the hinge theorem. So suppose you have these two triangles where you know that two pairs of sides are congruent and you know what the measures of the angles are. Now, if we know that 1 and 2 are congruent, we know that the triangles are congruent by side angle side congruence. But the question is, what if angles 1 and 2 are not congruent? However those angles compare will tell us how those sides compare. So for example, if angle 1 was 65 and angle 2 is 48, since 65 is larger than 48, that would tell us that BC has to be longer than QR. And if angle 2 was bigger, we would say QR is bigger than BC. But since we know that 65 is more than 48, we can make that conclusion that BC is longer than QR. So keep in mind, you have to know that AB is congruent to PQ and that AC is congruent to PR. If you have that, and if you know how the angles compare, that will tell you how the sides compare. The converse of that is also true. We call that the side-side-side inequality. So this is basically when you know all three sides and you're comparing the angle, that included angle, angles 1 and angle 2. So for example, same scenario, we know AB is congruent to PQ, AC is congruent to PR. And if we knew how BC and QR compare to each other, like one is bigger, one is smaller, etc., that comparison will also tell us how the angles 1 and 2 compare. So for example, if BC was 8 feet and QR was 5 feet, well, since 8 is larger than 5, we could make the conclusion that angle 1 has a larger measure than angle 2. Now, if those were swapped, if BC was shorter than QR, then angle 1 would have a smaller measure than angle 2. That should do it for 5.5 and 5.6.